Okay, welcome back. I hope you had a good weekend. We're a little thin today, seems like. I still haven't figured out if they had sync everything, so they put a big screen for us in the back for the students are facing that way, but I'll see if they left me a remote. Anyway, just quick announcement for my Thursday office hours for those of you who are making up lab or if you want to come in and get some help. My time is changing a little bit. I'm now subbing Mr. McLeod's class on Tuesday and Thursday in the afternoon. And I don't get out of the class until 5 p.m. But I will be in this room 5 to 6. Or a little bit after 6 if you need help for office hours, and I'll change that on Web Advisor and I'll send an announcement. But if you want to come in and use the computer and get some help with some Miss Lab, you can. Thursday is probably a good day to do that. Tuesday, my virtual office hours is also going to push back to 5 o'clock instead of 4:30. Okay. And okay, so we are going to work on system utility today. It's important because you will be able to use these for troubleshooting, for administering a network, to support a network. Also, for those of you who are in the cybersecurity program, it's important to learn these tools because sometimes you kind of have to do some recon, and these tools are helpful in finding information about system communication. That's mostly some of the areas in the recon. Okay. And reconnaissance is just, to really get the details about the systems, the weaknesses of the system, so that way you can build a better plan to be able to assess your system. At the beginning of the notes, it kind of gives you the overview of some of the tools that we're going to be talking about. I think you heard many of these tools throughout this class so far, but we are going to use them in our lab today. I want to focus a little bit more on the Windows side this week, and then we will touch on the Linux tools as we go. So for the first area, and we'll talk about our ARP is address resolution protocol. This is a very important protocol. This is how the systems is able to identify or associate MAC address with IP address, right? But in the below section, if you look, it really talks about how the address resolution protocol is used. So the way the system communicates is it's going to send out a broadcast message. It's kind of like you're in the room with everyone and you just tell everyone that you're looking for, right, a certain addresses or the people that live at a certain home address. So what it does is the machine A is going to send to everybody. It's going to say, whoever has this MAC address for this IP, raise your hand, right? And so the machine B from this group is then going to identify itself. So that's how it's going to receive the response and take that response and put it onto the table which exists on RAM in the system. So ultimately, that's how it's able to build the record of communication between system A and system B, right? And repeatedly, it would do that. But in between, you would have a switch, and that switch is going to be keeping record of which system is talking to which system by having a table of IP address and MAC address listed, right? So in the case that, let's say after the communication is done, a few hours later, the same communication needs to be established. It can go back into the cache or the saved information and quickly establish that communication again. So it streamlined the entire process by having that table. Now, on the security side of the house, we say, okay, there has to be some kind of record that is kept, right? So let's say that if you're an ethical hacker and you're trying to identify server system connection, you know that these table exists, right? You know that if the client needs to connect to the server, it has to transmit that information through the switches inside that network. So if you can have access to that switch, right, you would have access to the communication between the systems, their MAC addresses and their IP. Now, we want to protect this from the security standpoint. If you are defending the network, we want to make sure that we keep the record of ARP protected. Okay? All right. So that kind of gives you a little bit of an overview on address resolution protocol. So let's talk about the specific tool, right? When should we use these tools? How should we use these tools? This is the chapter that we're going to touch on this. So for number one, it says identify the networking utilities based on the following scenario. 1A, Jessica wants to display and modify ARP cache on the system. Which utility should she use? So let's say that Jessica wants to go into the ARP table, maybe delete an entry or add an entry to the table, right? First, Jessica needs to view the table by using ARP-A. So, and just to demonstrate this real quick, and I know you want to record your answer, but I want you to see the application in this, right? So if we open up command prompt and we type in ARP space -A, right? We would see on my system, right? It keeps a record of UC IP address to MAC addresses. And the same thing, you can do it on your system, right? And you notice that some of these are static, right? It's manually added. And then some of this one is dynamic, right? That means that it just automatically updates as it goes. Now, sometimes you would see some information that is stale. That means that it is not used, right? And it's been there for a while. It could be in the process of being removed, right? So all of this is actually inside the system. So first, Jessica needs to, number one, view the ARP table. How can I modify the ARP table if I don't see the ARP table, right? So that's why we need to use ARP-A to view the cache. And then if you want to set an entry, if you want to create or enter a static entry to the ARP table, you would do an ARP-S, and S stands for set. Okay? So it's simply that, right? In the notes, it gives you additional switch options. So when I say switch option, that's the little letter that's with the hyphen. Each of those have different tasks being executed with the actual command. So if you just type in ARP, the system would not give you what you intend for it to do. So first, we want to be able to view everything, all, right? -A is going to give you display all for your cache table. And then you can do the S to set in order to add, right? Or create a manual entry or a static entry. Okay. All right. Before we go into netstat, I want to point you back to the notes where you can find this information. Okay. And it's important that you kind of look through this, right? I added the notes so you can understand the details. So in the scenario A, 1A, Jessica wants to set a static entry. So we would do an ARP space -S. And at this time, she would need to put in an IP address and an associated MAC address to be added to that table. Now, do you have to do this for system communication all the time? No, right? But we can force it to have a specific entry that is static, that's manually added to the system so that way it can resolve specifically for that system connection based on the table. Now, it talks about the age, how it kept, right? Things don't stay in your storage forever. Otherwise, we would run out of storage, right? We have lots and lots of system communicating back and forth. So when you have static addresses that is set, right, it doesn't have an expiration when it gets deleted, right? It can be there permanently. But when you have dynamic address, it's only going to be there for a period of time. So that means that it has an age, and that is, you see there, about 2 minutes by default in Windows system. The reason why they keep it like that is because if you are adding another dynamic entry, if you don't use the previous one, it replaces it. So that way we can dynamically use the RAM on the system instead of taking up the buffer sizes where we would run out when we have a longer list in the cache. Okay. Now it talks about the registry also store the information. As you know, everything you configure, right, on the software OS level goes into Windows registry. So the registry is a database that is maintaining your hardware information and your software information for the operating system, Windows in particular, right? And so if you follow this path into the registry, how do I open this? I do a reg edit, and I will be able to look at the key listing or the H key listing. And since it is set for the local system, right, you're going to follow the local machines. And here, what you'd be able to do is you will be able to access the parameters, right? Now, the attacker from that standpoint, if they have access to the registry, they can do the same thing as you do, right? They can be your ARC cache and they can do that, right? So on the Windows Server system, we want to make sure that not everybody has access to the actual system registry to be able to modify it, because if they can, right, that will expose your system, or that would make your system very vulnerable. Okay. Now we can also do a reverse ARP or ARP. So we say that if we have IP to MAC address, that's a forward, right? Just like how you forward look up someone name to a phone number. Now when you do a reverse ARP, that is RARP, and it's going to take the MAC address and associate it with the IP. So it switch around. You can do this, not very, very common, but if I need to identify which MAC address to a specific IP, if I'm tracing someone or I'm tracing that connection, I can use reverse ARP. Okay. This tool, I'm going to tell you, is highly used in the security world. Okay. So I want you to be able to practice that today and see what that looks like. Okay. ipconfig is no longer used. Now, most Linux systems use IP address to be able to obtain IP address, as you've seen in your prior labs. But if you're using like old Red Hat or a Debian Linux, which it's deprecated this particular package with their network package. So they don't support ipconfig command anymore. Some textbooks still mention it. But if you ever run across a legacy, very old Linux systems, it will use ipconfig. That's equivalent to your ipconfig, right? And in Windows, ipconfig gives us the IP information for the system. And if you want more details, right, you want to add the switch, right? /all is going to give you everything about that network adapter configuration. Now, I know some of you know this. This might come up from interview or troubleshooting or on Network Plus, right? You would do an ipconfig /release to flush that configuration to basically reset it, right? So release allows the network adapter to get rid of the configuration that's previously there. And you would do this when you have trouble connecting or obtaining IP addresses with DHCP. We already saw how to make DHCP scope, right? A system boots up, it pulls an IP address from the scope. That's how it's able to connect to the network. But what if I don't like that IP address, right? I can force it to get rid of that IP address. Will it get the same? Likely. Okay, because the lease is for 90 days or 60 days, as you said it. But we can have it released and then re-obtain again, so that way we can troubleshoot the connection. Okay. Renew is how we obtain. So you normally do a release to get rid of it, and then renew to obtain new ones. Okay, so simply just do it like this, and I won't do it because it will just reset my network connection. So you're gonna do ipconfig space / right release like this and press enter, and then wait a few seconds, and then you can do a renew. So when you reboot the system, it does the same thing. So this is why they said just restart your computer, because every time your computer restart, your network adapter would send a request to a DHCP server to be able to obtain an IP address, and that's what it's going to use for the network connection. But if you want to force it, you can do a /release and a /renew. Okay? And so that's how we can use it. Any question? You can also use DH client, but sometimes they disable this option for the command in the network. Okay, let's go through and answer some additional questions. All right, B, the network administrator wants to gather the statistic of the system current TCP IP connection. Which utility should the network administrator use? And if I interview my network technician positions, right, for my team, I would ask these questions, making sure that they know how to troubleshoot, right? So typically when you get technical questions, if you're applying to do support or some kind of network related activities for that job, you are likely going to have to know these commands. So what you can do is you can use a netstat command. And netstat gives you connection statistic, right, for that system. So as an analyst, sometimes you would need to be able to derive that information. You can use something like Wireshark to be able to gather statistic for the overall connection with all the protocol. But as you know, if you administer server, some server doesn't have desktop, okay? It's just gonna be command prompt when you put it on, and you can only use commands. Some server, right, would have desktop where you would be able to use the tools like what you see with the Windows Server 2019 that we have used. So if I do a netstat like this, right, it's gonna take a second or a minute or so to do a reporting. And the cool part about it is it's going to give you the IP address and the port that you use for connection and the state, right? And so as you can see, so the more connection that you have or you have established, the more that you're going to see. So here you're going to see on my system, right? And as I am currently connecting, it has to build this out. So you would see some addresses that would be connected externally, right? And if you have internal server system that you're connecting, you would be able to see that. And then you have something that's established, something that's close wait, that means it's end, right? And so on. So it's going to give you a list. Sometimes it's time wait, that means it's still waiting, right? And so a lot of these, because I'm on my laptop and I'm connecting to Canvas and other servers, right? You're gonna see that a lot of these are gonna be HTTPS, HTTP. So this is a good way to kind of see. And so here we are with our school domains, right? You see that? Okay. So it's going to give you the information of what you currently connecting. And so you can also determine, right, you know, which domain that the system is connecting to. So this is a good way to see the information. Now, it doesn't specifically give you the numerical value, right? You have to kind of take this and be able to analyze it. There are options in it where in that if you use netstat plus an option, it will give you specific filter details. That's what you want. Okay. So that's kind of what you need to have for option B or scenario B. And then C, Jose is trying to verify host IP. and physical connection of his computer, which utility should he use, right? So easiest is going to be ping, right? And so what we can do is we can ping a specific address like this address here. So the target system or Jose's computer, the host IP, it could be this IP or another IP address, right? Arbitrary, we can say ping 10.0, what's it? .8.138. If that system is connected, then I should be able to receive some reply, right? So it's saying reply from, right? It's actually another system that is intersecting, right? So maybe I'm trying to cross over to a different part of the network because I'm on this segment, right? So it actually expired in the transit. It never really got to the 10.0.8.138 because something has intervened and dropped my request. So this is one way that you can also block a different part of the network to check the status for a connection. Now some admin, they would disable the ping command, right, from different segment of the network so that way someone cannot attack them with just a bunch of ping requests or the Smurf attack. But you can see now if we do this and we ping our own system, I normally recommend doing a loop back first. Right? And as you can see, we have 100% success with the loop back, right? And then we can also ping our own IP address. So ping would probably be an ideal troubleshooting utility to verify connection or connectivity. So I would recommend using a loopback address to start and then that specific system IP address. Now, how can you do that? You can do ipconfig, obtain the IP address, and then ping it. So if you have 100% success with 0 loss, then that system is connected to the network. Any question? Okay. Next scenario, a technician needs to troubleshoot a conflict with NetBIOS of two systems in the network. Which utility should the technician use? So a conflict occurs when people install OS and they manually give the computer a name that is the same. You cannot have the same identity in the same network. Right? Same IP address, no. Same MAC address, no. Same host name, no. Right? It has to be unique because how is it going to determine is it system A or system B, right? It has to be unique. So in the case that if they make a mistake and they use the same system name, right? They need to be able to resolve it. So one system has to change its name, right? But because there's a conflict, what we want to do is we want to be able to use two commands. First is a hostname command to verify the actual computer name. Second, we should use the netstat. This is related to your NetBIOS, right, service. So it's going to give you the information on how it resolves the system by name, right, in the network, okay? So two tools that you need is netstat and hostname. Now, hostname is the same in Windows as it is in Linux. So if I say hostname, right, you saw this before, you would see this is my computer name, right? But now, if I have another system that has the same name, then the second system or my system will not be connected to the network if it uses the NVT, if it uses NetBIOS. Okay. So netstat gives you the status, right, of that system resolved by name or using NetBIOS. Question? Okay. So, some of the things that I wanted to kind of touch on that we didn't talk about in the assignments, right? Sometimes when you are trying to connect, like you would have people call and say, I can't connect to this website or this domain. I couldn't connect to that network. So you need to make sure that your DNS connection is can be established. One way that you can check your DNS is you can use ipconfig and then you can do a /display DNS. I normally use nslookup, which is more of an easier way to kind of identify where is your domain. So for example, right, if you do ipconfig all like this, it normally tells you here are your DNS server, okay? Without your DNS, without your primary controller, right? When you do a lab, when you install DNS, you're gonna see, right? You have to promote that. It becomes a domain. All your system would need to connect to it in order to authenticate and access through Active Directory. So as you can also see that we've seen that BIOS right here, and that's enabled, right? So if you want to, if you're saying that, oh, I can't connect to the DNS, you can also display the DNS, but you can do nslookup, right? And it specifically tells me, right, that this is the actual server that I'm connecting to in that network. And this is its IP address, okay? So if you don't see this information here, that means that the system that you're checking on is not connecting to a domain, okay? So my question for you is, how do I connect a client system to a domain? They love to ask this question when they interview students for jobs. So how can I join? Let's say I install Windows 10 or Windows 11 on a desktop, right? In a company. Now I need to get that system to connect to the domain that is on that network. So how do I join? You want to know? Yeah.
I think I might go through the IP settings.
Through the IP settings, okay, so you can put in your preferred DNS, but you still have to join it. Right? You can put in the preferred DNS, and you saw this last week, right? When you did the server, you put in the DNS server IP. So you're pointing that my system is using this DNS IP, but you still have to join it. It's really easy. Okay. Let me minimize this real quick. So to join your client system, right? Do you know how to reset your computer name? How do I reset my computer name? You can go into settings, right? Go into your systems, right? About your system. So do you see this, rename this PC? You can also do this in control panel for Windows, right? So you would normally in setting, you can only reset your computer name this way, okay? And it's only gonna let you change the name. In control panel, if you go into systems and security and about your system, right? There's an option that you would be able to identify the system with the rest of the network through your system configuration. Now, you have to join it. Once you join it to the domain, so here I am, right, at RCCD, I just connect to the wireless network, and it automatically connects me to the DNS. But on these desktop right here, they have to join it to the actual network in order to do that. So you will have a lab where you're going to create a DNS and you're going to join your Windows PC to a DNS, because leaving my class, you have to know how to do that, right? That's one of the things that you need to do. So ultimately, to answer this question to the interview, is all you have to do is to go into your computer settings, right? You can say that You can go into settings, go to about. In your computer settings, there's an option that you would be able to set it to where you would join the DNS, and you have to put in the actual full FQDN, your full qualified domain names, okay, to be able to join. Okay. All right, so we will. You see this advanced system. I was ahead of myself by telling you that, right? And so what you click advanced system settings here, computer name right here, you click change, right? You see this option right here? You see that? That's how you join a domain. So again, right, go to your system settings and be able to do that, okay? Excuse me. Okay. All right, so let's talk about telnet. Telnet should not be used in a regular network because one, it is in clear text. It's not encrypted like SSH. So when do we use telnet? Well, we use telnet to connect a system like a laptop or a desktop to a switch, a router, or another computer. You can, when you establish that connection, it creates a terminal window, just like how it sounds. Like in Linux, you know how you open up the terminal? So it's like a CLI environment where you can take control over some of it if you have the appropriate command. So basically, you can directly connect to that system, but your connection is not encrypted, which creates a problem because now if someone is able to obtain that connection, they can reconnect to that system, right? Or they can also capture the information that's sent. You should always use SSH, which uses encryption and it protects your communication channel. It protects the messages that you establish or send between the systems. So it's important that you use something that's more secure. So if you see telnet service in the regular network, that should be disabled unless it's absolutely necessary that you use it, then you turn it on, right? It's often used in an older system. It has very weak or no security. You can use remote desktop protocol in Windows system, or SSH also in Windows is okay. You can use SSH in Linux. When we get to the routing and switching lab, you're gonna see that we are gonna use PuTTY, which is an application that allows you to directly interface in and connect into the switch so you can configure the switch or the router. And in order to do that, right, you would have that communication. So if I need to connect to a cloud instance, that's the same thing. I still have to go through the network, right? Like my service provider to exit my regular network to go into WAN. But ultimately, RDP is going to get you there if you want to remote into your Windows server that's on AWS cloud or whatnot, right? Or you can also use SSH to be able to do that as long as you can connect to the actual server through the network if you have internet connection. Okay. Question? Okay. So ping, we talked about ping. It uses ICMP. We touched on that last week. You're going to do the lab today and you are going to do ping with count. In Windows systems, it's a little bit different when you're using ping command compared to Linux. Linux also use ping, right? Linux, if you just do ping and an IP address, it continues to ping until you cancel it, right? Which is Control-C. But in Windows system, if you do just a ping and an IP address, it sends 4 requests and wait for 4 replies. So in that case, you're going to see ICMP echo and request in the traffic if you run Wireshark. You can also have it count. In the lab today, you're going to do an option N, which is a number, right? We can use -N and then we can do like 8 times, 10 times. So if you want to send 10 requests, you're going to do ping -N 10, right? And then the target IP address. So that's how you can do that. But in this section, it talks about how you can implement, right? Different options with ping. A is for a pen, and you can use that like a host name instead. So I can ping a computer name, okay? I don't need to ping an IP address. So you can do that. A pen means that it's going to add the string or the text into that function. So you will be able to have the different options there. You can also set a size for your packet. Because if you ping, it automatically defaults to a certain size, as you know, right? So if we want to change the size where we want the ping packet to be larger or smaller, you can also do a -L and then specify your size in megabytes, right? There, okay. Or bytes, I should say. Okay. So some example, if you're doing like ping-6 versus ping-4, right? This is gonna implement for version IP version 6 or IP version 4. So it's a way that we can use ICMP, right, in different versions for the IP address. So I talked about echo requests. So if you're curious today, when you run that, right, sometime at home, you can do a ping and then open up Wireshark and you can see, and you can filter out ICMP. So you should be able to check all your packets coming through. So if you're getting a Smurf attack, right, you are going to see a flood of ICMP requests coming through. Okay. And it's just going to drop. So that's a denial of service. So what you can do is a lot of times what they send it through a proxy or a server that dilutes that into the other area of the network. So it stops it before it even gets to the target system. So. Okay, let's move along. Okay, so for number 2, it says, when does ARP broadcast occur? So when you have IP and MAC address entry that is not stored, that's not cached. So cache just means that it puts it into memory or buffer. So if the system connection is not stored, right, it doesn't have a reference. So it just have to send it to everybody. It's kind of like, I don't remember your name, right? I'm in a room with a lot of people. So I keep saying your name out loud, like, who is Patricia, right? Until someone heard me and tell me that, oh, she's Patricia, right? So what happens is you're gonna get a continuous broadcast until a system identify itself. So that way it will have an entry information inside its storage. Okay. So now when you have broadcast, remember that it's gonna take a lot of bandwidth. So you don't want the broadcast to be continuous. We want that for the first time, but after that, it should not happen again. So once it's recognizing the other system IP and MAC information, it's then gonna store it, right? So it would only broadcast if it doesn't have it in the list. And then it asks you, why does the system store ARP information as cache? Really to reduce what I just said, right? So it stores it so that way it remembers. So in the case that if the two system needs to be connected again, it has a reference information on that list to be able to go to. So that way it uses less of your network bandwidth to resolve that address. So if all your system are broadcasting all the time for ARC, right, your bandwidth is just going to drop tremendously. So initially, it should only send broadcast the first time. After it has that information, it would then put it onto RAM. So the lifetime, we talked about this initially, is 2 minutes. If it's reused within the 2 minutes, it stays on for 10 minutes. Okay? If it's not reused within 2 minutes, it gets cleared out. by default. The difference between your reverse ARP and ARP is that reverse ARP translate MAC address to IP and ARP translate IP to MAC. So it's the opposite. Any question? So I think a lot of these tools, you're gonna see their components in security tools, right? So if you use these utility and you're familiar with them, you would see that a lot of the scanning tools use the functionality of some of these utility, like ping, right? Or even ARP. Okay, so let's move forward down a little so we can look at the next section. Okay, so what command do you use to remove an assigned IP address from a system to obtain a new IP address from the DHCP server? I talked about this, I showed you this, right? ipconfig release to remove the assigned IP address from the server. So the server gives me an IP address, I don't want it, then I can do a release. And then that will flush everything, clear it out. And then I do an ipconfig renew to obtain a new IP address from the server. Okay. So the command that you can use to renew an IP address in the Linux system, you can also use DH client, which is DHCP client, which obtains a new IP address. I normally, the best command that you can use in Linux to obtain the IP address, reboot. That's the best, right? You saw, some of you came across some issue when you set up your IP address in your Linux system, right? I just tell you and sometimes when you configure and if it's not going the way or it's not updating right away, right? It doesn't have your new IP address stored, right? You reboot and you see it. So when you reboot, your network adapter has a refresh and it's going to give you the information that you configure. So always reboot after you configure Windows or Linux. And you can find all of these on your notes. For question 8, what command do you use to view DNS resolver cache information in Windows PC? To clear DNS resolver cache, so you can do ipconfig /display DNS. This allows the systems to display the stored DNS information. And if you want to delete it or clear it, you can do ipconfig /flush DNS. And that will clear the DNS. So sometimes, you know how when you open the browser and let's say you have some issue connecting to the internet, you get that white screen, it says, uh-oh, right? You don't have network connection. Check your DNS resolver information, right? So it's going to give you a little bit of hint on that page. So in the case that if you cannot connect to the DNS, you can flush the current information from the DNS. Why is that? Well, sometimes some domains get rehosted elsewhere, right? It might not have the same domain information anymore, or the domain doesn't have the associated public IP address as it was before. So your stored or your DNS information might be stored that's old, right? It's aged, it's no longer used. It's kind of like you're trying to find someone that used to live at that house and you go there and no one's there, right? So we have to get the updated information by clearing it out and then reobtaining the DNS information again. So when they move server, when they change server configuration, you tend to run into this problem, okay? Guaranteed. So long ago, we hosted Cyber Patriot for the local high schools like Canyon Springs and so on. And I just got started teaching here. No one was on staff for IT on Saturday. So I took on the task to be able to help with like troubleshooting. And they were trying to connect to the server that was hosted by the Cyber Patriot competition provider. And for some reason, it was just older information based on their system. So we had to flush the DNS. And so some of the faculty who was running the Cyber Patriot team, they're like, oh yeah, I remember talking about this, right? So in application, if you change DNS configuration, you have to clear it, okay? And then renew it. Okay, ping utility uses ICMP, Internet Control Message Protocol, right? When you ping, it sends a request. Your system that is receiving the ping, the IP address, right? That system is going to do an echo for the reply. The option that you would use for the name is going to be ping-A for a pen. And then you put in the host name like computer 100, whatever. Any question? So you might get questions like these on your certification exam, right? They are going to be specific to, a lot of them is going to be like practice-based questions. So you have to know what to use and how to use it. But on the job, you need to know how to use it and also what to use. Okay, so let's go through 11 real quick. Now, I highlighted the numerical value. This is going to be the number of packets that it's going to send. So when you do a ping-n, this is in Windows, of course. And the value here, the numerical value here indicate the number of packets that it's going to send for the request. And then your target IP, right? So this is a loopback address. So we're pinging ourselves 10 times, okay? So you can try this on your computer and you can see, hold on, let me scroll this up a little. Sorry. Right? I'm trying to leverage the screen. Okay. So we have to exit out of nslookup. So we're going to do a ping -n, and then you can put in the 10 and your target IP address. Some of you already know how to do this, right? So you're gonna see that it's gonna send 10 requests and you receive 10 reply, right? Because by default, Windows only do 4 packets. So if we want higher or lower, we can use the option N and then the numerical value there. Now, if you want to do a certain length, right? We talked about this before, right? We can do, I can replace the option N with the L, and I can put in the byte size, okay? So we can try ping L 128 for 128 bytes, and then we would put in the target IP address. Okay. So this one, it sends 4 because I didn't change the count for my requests, my packets, but I changed the length. You notice the byte size is different because the default byte size is 32 bytes. And when you do the length or the -L, it changed that. It increases your payload for that particular packet, and you have 128. So also, you notice your TTL is different. We talked about that last week, right? Because your packet size has increased. So your time to live also changes there. Okay, so we can do until terminated. We can make it go forever, which is the default in Linux when you're using ping command. So if you do a ping-t and your target IP address, how many packets actually sends? It sends as many packets until you terminate it. So if you let it run longer, it's going to send more packets. If you make it really short, you terminate it early, then it will just be however many packets at the time that you terminate. And then if you use the option K before the IP address with ping command, it would exclude that host IP from your route list. So in the case that if we want to exclude a certain IP address, we can. You can also ping a range. I think some security tools are way better than just using the ping command, that it would allows you to ping a group of IP addresses on the Swift, depending on the functions on how they program. They wrote that in code, right? But ultimately, ping can go a long way by just, checking the status of your system, how it, your system respond when you send the request. Now, if you're using IP version 6 address, you can do a ping-6, which indicates IPv6. And then for Linux, you do a ping-6 together, one word. Okay? So that, and then we would follow that with, of course, the IPv6 address. Oh, right. We can't just do a ping without the target IP. It's going to complain, right? Your command prompt or your terminal is going to say error, right? You're missing parameter. So we would do a ping-6 and then our IPv6 address with the colon, like what we talked about last time. Any question? Okay. So let's bring 12 down. So when you receive timeout, right, it says 13. When you're using ping and receiving reply timeout message, then you try to adding time value with the option W, and the whole system is returning replies. What could be wrong on the network? And this is common, right? So let's say that I'm trying to ping a system and I'm getting, reply timeout. That means that it cannot reach it, right? But instead of unreachable, it's saying the reply timeout. It could be the system is busy to respond. So, but we are going to add the time value with another option to see if it gets to a reply, right? That means that your packet is arriving, but the timing out is before 4 seconds. It's too short. There's a small window that it needs to reach, right? So the 4 seconds already expire as your packet is still arriving. So it's late. Okay. So that means that you have bandwidth problem when you see this, and or what we call that as latency. There's a delay, right? It's kind of like you are receiving package from your friend, you get the notification for that package, right? But you don't see the package until a day later, right? And they're saying, oh, FedEx just delivered. You ever get that? I'm like looking for my package. FedEx delivered where? Where's my package, right? A day later it arrives. That happens a lot in Moreno Valley. I don't know. But anyway, so what happens is that 4 seconds time up it's already been up, but the packets is still coming, right? So there's delay, there's traffic in Moreno Valley, and my FedEx van is not at my door, right? So you have latency on the network. So that means that we have network bottleneck or some kind of issue that we need to fix. Maybe transit systems that's not having throughput, maybe cables down, a lot of things. So we have to check physical and software level to make sure that we fix this problem. Okay. So that's one way that you can check to see if you have bandwidth problem. Okay, then you do ICMP message. So what type of ICMP message is used to echo requests and echo reply, right? We can use ICMP 8, which is a value. Remember, we talked about ICMP code and type last week? No, don't remember. Go back and look at the notes, right? So basically, this is a code numerical value to indicate what type that is, right? So the request uses the 8 for the code, and the reply uses the 0. Okay. Okay, so here it talks about the type 0 and type 8 for requests. So if you're curious where that is, it's on page 4. And then HPing 2, which should be a really good tool for security people, right? It is popular, so instead of using ICMP, which can be blocked, right? Because sometimes you would have administrator that sets up ICMP, block the port, block the service. You cannot ping any system on the network. The way around that is to use hping, and you can visit hping.org to, I think Kelly has that equipped. This is good for firewall testing, right? Assessment for vulnerability. So if you want to do advanced port scanning, I think some of you already took my ethical hacking class. You already saw some of this, right? So hping tool is often used in security to test your firewall. You can do a lot more. So remote OS fingerprinting. So when we do fingerprinting, we actually want to find out what kind of operating system that system is running. So you would do hping 2, for example, 10.0.0.1, and you want to see that system that you're pinging, what operating system is it running, Linux or Windows, right? You can also do a lot of other things by doing hping and hping 2. Okay, so to do custom packets, you can use hping 2, and it uses TCP, not necessarily using ICMP, but ICMP is part of TCP, but anyways, TCP. And then if you want to determine the number of routers, right? We saw this when I showed you trace route, between your source and destination system. What utility you use. In Windows, we would use trace RT, right? Don't say tracer, trace RT, which is trace route. And in Linux, you spell it completely out in one word, trace route. So we would do trace route and domain name or IP, right? I showed you this last time. So we can do trace RT, right? We can say google.com. And these hops just represents the network or the routers in between your system and the destination system. So you can use domain name without the www or the IP address if you know it. Okay, so if you want to speed up the trace but not show too much things, because remember, when you trace it, it has to report back to your system. So it takes twice as long or even more, right? So you can use trace RT in Windows system with the -D to avoid displaying maybe some host information. And then if you want to do google.com over 20 hops, right? So you want, let's say it's kind of like this. I put a camera on your car, right? And I want to follow you from your home to your work, right? That's regular trace route. Now I can put the camera to your car, but I'm only following you for 20 streets, right? So we can do an H20 that allows you to look at the number of hops. H stands for hops. Those are routers. So it's only going to trace up to 20 hops. Now, what happens if there's less than 20? Well, that's less than 20. So it's in the 20. So it's going to give you everything. But if it's 40 hops, right? Let's say you have to go to 40 streets to get from home to work. I'm only going to follow you halfway, right? I'm going to track you halfway or trace you halfway. So the hop count here can be indicated or specified for your target system. And then if we want to do version 6, right? We just do a trace RT -6. Remember, no www in the front. You drop that and you just put the domain name, okay? Or the IP address of Microsoft.com, for example. Let me see if that works. Sometimes they don't. Now, see how this is long? Because sometimes it doesn't let me, and sometimes it could be that their systems are busy. So you can press Control-C sometime to kind of help it out a little bit, because it tends to kind of stall a little bit. So these are the hop numbers. So these are the routers in between from where I am, right? My network to their network. And then the trace complete. So it shows 9 hops. Now Windows is going to give you the maximum 30 hops. I've never seen, right, 30 hops in my whole entire career. Okay. on Windows command prompt. Usually it's a summarized version, but so, and if you want to repeat command in PowerShell or Windows or Linux terminal, up arrow key, always repeat the last command because that saves to your RAM, right? So we can do a trace RT and we can do a -6. Let's see if Google has it. Can't resolve for Windows. Let me see, Microsoft had it. Sorry. Yeah, if they don't use it with for the public IP, you won't be able to trace it. Okay. Mostly IPv4. Let me see if clear's still clear. Okay. So what information is provided in netstat? You saw this already. Protocol type sometime, local address and port information, remote address and port information, and the current state. So when we look at netstat, right, we would see that we have the local address, the protocol information, the foreign address, which is the destination system, and then the state. It says foreign, but because it's not to your computer. So your computer, destination computer, the state that's established, right? The protocol information. And that's for your active connections. Okay. And then we want to display the system NIC statistic, right? If you want statistic, you can do a -S. Netstat with a dash lowercase s gives you statistic. Whereas ARP with the lowercase s means it's set entry, right? And then if you want to only display traffic that is UDP instead of everything, you would do P for protocol and then UDP for netstat. And as you know, when you ask for these things from your system, sometimes, if you're connection is still being established, it's gonna keep updating, and sometimes it takes a little bit of time, so you have to be patient with it because it has to report back to your system, right? So it's gonna retrieve the information and report it. So we always talk about telnet, right? I remember one day one of my upper class students a long time ago, he was like, you always talk about disabling telnet, but I don't even know how to run telnet. So to run telnet, right? In Windows, you would run the executable telnet.exe. Okay. In Linux, you open up your terminal, you do a telnet, and then your target IP. Now, as you run telnet.exe, it's going to open up your terminal for telnet, and then it would ask for the target IP address, which system you're trying to reach, right? So that's ultimately it. Any question? This side, yeah.
So are any points, expensive or you can write it all captured all of this?
I think in command prompt, it is non-case sensitive, so you're generally okay, but we always use lowercase because it's command. Linux is case sensitive, PowerShell is case sensitive. For most part, it will understand your command, but the parameters, you gotta be careful because the way that they write the function, because it appends in, for example, like the string, sometimes spacing and stuff in PowerShell is a little, because ultimately it's Objective-C. And the way they write it is it runs these sub-modules or components of the application separately, like set and get functions is separate. It's not together as an applications like that. So yeah, those are the things you want to watch out for, is just in PowerShell, but in command prompt in general is okay. Linux is case sensitive. Okay. Any other questions? Good questions. Okay, let's move down to the next few. So Telnet uses port 23. I always remember SSH is 22, right? And Telnet is subsequent to that, so it's port 23. So learn your port number. That's going to be important, especially for the IT and cybersecurity fields. We always refer to the common port. So whenever that you see, so when you run the Wireshark, your system is trying to reach another system with Telnet. You're going to see that you're going to use dynamic port. And then the system that's receiving for the Telnet, right, the target IP system is going to use port 23. You saw this with DNS and other things when we did the Wireshark lab. So port 23. So now Telnet, like I said, it's in plain text. So there's no encryption in that communication. That's why we try to stay away from using it. So for example, if I sit down and configure my firewall and connecting to it with Telnet, right, someone can intervene and be able to pick up my information. They simply need to do what? Scan the network, right? Because I am connecting to the network and the firewall is connecting to the network. So if they're part of the network, then they can scan me and they would be able to analyze my traffic and open my packet information. So when you look at that packet, the Telnet packet, you can tell because it's that port value. And then, right, you can find some payload information for the messages that will be exchanged in plain text. So you might be able to grab some information from there. So that's the risk behind it. So anything in plain text in the network environment is not ideal, right? It's not recommended. You would be imposing the risk in the network environment. So now FTP servers are still abundant and common. File transfer protocol, this is used to be able to share files, upload and download files. Now FTP has two modes. One is going to be text-based mode, which is using ASCII encoding system. Two, it would be the binary. This is going to be for executable files. So if I'm going to upload like application files like exe, right? That would be binary based. So those of you in programming, you already know your bin files is going to be used for the development piece, right? So binary is for executable file. And then if I have documents and forms in text, for example, like insurance form, you know, plain text stuff, right? That will be text-based file. So traditionally, FTP is built for just that, to be able to share files with people across the world or within your network, right? But FTP server also impose risk. So every system, now we looked at it, we're like, what kind of service do you have and how do you protect that service? So if you're using the service, you just have to know that it has weaknesses, and so you just gotta beef up in some protective area because we're taking the risk. Okay. So how do you connect to an FTP server, right? I know these questions are plain and simple, but I want you to make sure you know the basic, because when you get to other security classes, you know, okay, this is how I connect to the server. This is how someone connects to the server. You basically use FTP command and the server IP address, right? Or the domain information, like Mozilla runs FTP servers. So whatever the .com, .net, or whatever, right? You can do FTP so.com, right? FTP, right? 14.2.38.x, etc. Right? So basically, you do this in your command prompt or your terminal, and that's how you get connected, right? So if that server allows connection, it would usually allows you now to log in. So you would have to log in by using username and password. Traditionally, before, you can use anonymous as a login, but now they do away with that, right? Because of security reason, we want to make sure we know who logs in and who downloads what and upload what, right? In Linux, if you set up an FTP server, you have to do Windows directory permission control now in order to do that. I think I did this for one of my lab for the other class 27B. But that's how you do that. Okay, let's go through some of additional FTP command. So you can use this to automatically log in. I know anonymous account is not used anymore, right? For most FTP server. So when you do ethical hacking, you got to scan for it. You want to see if the anonymous account is still there. If it's there, then to automatically log into it, you do FTP-A, which is for anonymous. You're gonna do anonymous, the group, right? Anonymous, hence the name. That's how old that was, right? So anonymous is just, you don't know the identity. So now we want to make sure that there's accountability in the user account in access control. So you want to make sure that everybody authenticate to individual account. If you want to disable automatically login, right, in your server, you open your terminal and you do an FTP-N. Okay. I know we talked about a lot of different servers. I want to kind of make sure that you know how to use some of the very basic. For 28, what type of service allows you to back up router configuration, Cisco network operating system like your ISO, and your device configuration? This particular server is made for that. Images, system configuration like wireless router configuration. You know how when you set up your wireless router at home, it tells you to back up that to a USB? Well, in an infrastructure and enterprise environment, we don't put things on USB. You lose the USB. You put it on the server. So in the case if another technician, another admin needs to have access to it in another region, you can just log into the server and download the configuration. So that means that we don't have to repeat the same thing. So if I have 100 routers, the same brand, the same model, I already pre-configured maybe 4 or 5 of them. I can back that up and I can put it on the server. Someone can pull that down and set up their routers in California, in New York, etc., without having to do a lot of the base work. Okay? So TFTP server, trivial file transfer protocol, that's what it's made for. You can also do other form of servers with this, but traditionally this is what it's used for. So TFTP, you can find it on page A and it goes over the detail. The difference between FTP and TFTP is that TFTP mostly use UDP. And it's mostly used for configuration, operating system for your switches, your routers, could be for Cisco, other brands. And it would be able to handle permission control for the files that you put on there. Any question regarding TFTP? Okay, let's talk about DNS. I show you how you can do DNS, right? Look up. So if I open up command prompt, I did not want to open that, sorry. Type in. And if you do nslookup, it would tell you the actual domain that you're connecting to. And you from here, right, you have, if you want to get back to your pop-up on your command prompt, you have to do an exit to get out of that, but it tells you the information for your DNS. So DNS is your domain name server, right? This is gonna allow you to have domain, right? Like the .net.com, right? mynetwork. etc. right? .edu, for example. So when you install the DNS, you would need to be able to set that up. And in that process, you would have a record of the IP address, which is for your server. For example, 172.16.0.28 tied to myserver.net, right? Which is your domain name. And that's a forward lookup, so that way it would give you, right, the information for that. So if you're using IPv4, record A, which is the file that it creates, that's going to associate the IP, the name to the IP, your FQDN to the IP. So when you do an nslookup command, it goes to that file and it's going to give you the information, which is what you see here. So when you look at your nslookup like this, right, that's from the record that's stored on that server. Okay. Now, I can redirect you by changing that, right? So if I have access to your server A record, I can go in and instead of that domain, I put in my own domain. And this is how you can redirect, right? So we have to protect the A record. Now, if you're using IPv6, it would use the quadruple A record, AAAA. And we would still be able to find that with nslookup. It would just tell us, right, IPv6 information that's associated with the domain name that we have. Now, when you install that, you have to specify which one you want, IPv6 and IPv4 or one or the other. So you will see this when you do the lab later on. Okay. So one of the cool command that you would use in Linux, if you want to do something similar to nslookup, is dig, D-I-G, okay? And this allows you to query the DNS for Linux systems. And you can do it with all of these options: port, name, key file, version 4, version 6, etc. And it goes on. So if I don't know these options to start, I do a dig/help, and it's going to give me the basic options so I can start there. The cool thing about Linux is you can also read the man pages for the actual command to be able to do more with it, right? So for 30, this is what command do you use to gather, summarize information of the IP address of a fully qualified domain name, FQDN. Provide an example. We can do dig, right? Your website, and then you can do a plus short. So that's a summarized version. If you want in Linux, if you want anything to give you the full details, you know how you put full details on some things, right? That is considered verbose, right? So when we do a short, it's just a summary of that domain information. Now, not all public DNS allows you to see. Some of them they shield. So if you try like Instagram, Facebook, they block all of that. Okay. You have to go through a security company to be able to obtain their information, because they know that people recon them for attack purposes. So they shield that. Okay. It's kind of like, using an extra service to make sure that people don't get the details of their server. So you see the big tech companies, they have that shield. So you can't just do that to anyone. Now, some people, right, later on, if you take ethical hacking, you're gonna know, can I use this command for public domains? Sure, right? But the intention on what you do with the result is really gonna tell you whether you're ethical or not, right? Sometimes we see information, how we use that information is important. You are privileged to a lot of sensitive information in this technical area, right? Especially in networks. So we just have to be mindful of that. Okay. 31. Identify the utility for the following criteria. Okay, identify specific types of server on the network. You would use the command call host. Host really identifies systems information. Unlike host name is really specific to the computer name. So each server has a computer name, but sometimes the server would take on the role, right? We talked about that. So the host is going to tell you the server type. And if you use MTR, this sends multiple ping messages to many routers. See it. And each of the router between the source and the destination, right? So just kind of like your trace route, but what this does is it's going to ping as it goes. So just keep in mind that it's going to be slower. And then if you want to modify or manage your route table or see it, you just do a route command. In most systems, including Windows, route will also give you routing information. Now, if you're using Cisco router, they have specific things for accessing the table. We'll see that later. Okay, so after this, we'll stop the video and take attendance, and then take a little break, and then we'll do the lab, right? Okay, the last part, if you get through the notes, right, I encourage you to read through it, because I'm just giving you the brief cliff note lecture versions, right? But go through the notes, read the information, try to understand the terminology and the utility and how it's used. So in troubleshooting, you always approach the problem. We talked about like physical and like hardware and software before. But for the network issue, a lot of the times it's named resolution issues with the DNS. So in the case that if you cannot connect to that domain kind of error, first you're gonna check for the local name. Okay. Then you are going to check for the DNS. We can do nslookup, right? We can do host. Okay. Then we're gonna check for Win services. Look into your host files and the LM host files. This is on the DNS configuration files. So let's say that you install DNS, you put it up, you promote it as a domain, and the other system could not connect to it. You have to go in and look at your configuration for your DNS systems, right? And your Win system, check your host files to make sure everything is correct, right? So we have to backtrack our steps. And then what we're gonna do is we are gonna generate a broadcast so that way it sends the information to all systems, right? And see if your client systems are able to obtain that information so it can connect. Okay. And then we're gonna check also for NetBIOS. So we talked about nbtstat earlier, right? So that's how you check it, is to use nbtstat command. Okay. Any questions? Okay, so if you missed the earlier announcement, my Thursday office hours is pushed an hour back. I will not be here at 4. I will be in this room on Thursday at 5 o'clock if you're catching up with work. I picked up a class to help out. Mr. McQueen is out for a while due to medical reasons, so I'm now gonna teach CIS-5 on Tuesday and Thursday. I will also change my virtual office hours for Tuesday for my online students in case they need me, but you can also pop in. So I will try to send out the announcement in case you don't have access to all of that on Canvas, in case you need me. Okay. All right. We'll go ahead and stop here.